Okay, so in this video we're going to calculate the Taylor polynomial for 5 terms at the point 0 for the function of sine. So when calculating a Taylor series, it's important to know what function you're dealing with. So in our case here, that's pretty clear, it's sine. The point A, at which you're going to calculate it at, in this case it's point 0, so A is 0. And the degree n, well the degree n means how many terms you want. So in this case we want 5 terms. So n is 5, a is 0, and the function is sine. So let's move on to the next stage. So this here is our Taylor polynomial general formula. And you can see here there's a lot of n's and x's and a's. Basically just all you got to do is plug in, or a in this case is 0, so all these a's become zeros. The n would become a 5 because it's the 5th term. And this f of a is just the value of our function at 0. So that's the value of sine at 0. And then we've got on these fractions here are first derivative of a over 1 factorial, second derivative of a over 2 factorial, third derivative of a over 3 factorial. And you can see here now there's a pattern forming. The 2 on the top, 2 on the 2 factorial on the bottom, and the 2 as in squared. Then there's a 3 factorial cubed, 4 factorial to the power of 4, and that would be true all the way along this function. So you can see here f of n, or f the nth derivative of a, n factorial, x minus a to the power of n. That's true for all terms. If you had 15 terms, you'd have the 15th derivative, 15 factorial, x minus a to the power of 15. So now we can plug in a few values here. Now we've narrowed it down what some of these mean. So we can do the differentiate the function of sine 5 times, and that'll be our first stage. So each derivative at 0 is what we're interested in as well. So first of all, the function is sine, and the value of sine of 0 is 0. So that's pretty straightforward. Then we take the derivative each time, and it's good to make a nice little table like I've done here so you can see you're working nice and clearly. Then if you made any mistakes you can go back, put them right, and it's pretty straightforward for you. So the differentiate sine, you get cosine, and cosine of 0, which is the first derivative of 0, is 1. So that's how we get to this stage here. Then the second derivative of sine, which is basically the derivative of cosine, is minus sine. Sine of 0 is 0, so the second derivative is 0. Third derivative is the derivative of minus sine of x, which is minus cosine of x. Well, we'd already worked that out here, so you can just keep following on. So sine goes to cosine, so therefore minus sine goes to minus cosine. And then the value of minus cosine at 0, well, cosine of 0 is 1, so minus cosine 0 is minus 1. Fourth derivative of minus cosine is sine, and sine at 0 is 0. So that's straightforward there. We'd already worked that out here, and we'd already worked that out here. And again for cosine, the derivative of sine is cosine. We'd already worked out that derivative here, going from the function to cosine. So here again we're sine and then to cosine. And the cosine at 0 is 1, which again you'd already copied there. And this pattern, sine, cosine, minus cosine, will go all the way down the line, all the way down for an infinite amount of derivatives. So we follow that pattern. So sine, cosine, minus cosine, then sine, cosine. So the 6th would be minus sine, the 7th would be minus cosine, and so on. And then all these values would all follow on as well. So now we've got all these derivatives, we can start to plug that into our Taylor polynomial. So first stage is just substitute all the a's for zeros, just do it in one step at a time. So the first derivative at 0, which we've calculated, second derivative of 0, which we've calculated, and x minus 0 squared, well that's just x squared. Then all your factorials here, well your factorials is just 1 times 2 times 3 times 4 times 5, whatever number of factorial you want to go to is how many times you multiply. So that's going to be straightforward. So therefore we can now get ready to get to how we get to this answer. So the value at 0, which we calculated here, is 0. So this first term would disappear. You won't need that. So here you could put a 0, but we're not going to put a 0 there. We want to keep it simple. So the first derivative is 1. So then you've got 1 over 1 factorial, which is 1. 1 times x minus 0 is just x. So that's how we get to this first term. Second derivative at 0 is 0. So this second one will disappear. That's why there's no x cubed value in there. Then we want the third derivative. Third derivative is minus 1. So here we put a minus 1. So we just leave it as a 1 and then flip this sign to a negative. 3 factorial we know is 6, so it's 1 over 6 times x minus 0 cubed, which is just x cubed. So therefore we get x cubed over 3 factorial, which we've then simplified here, x cubed over 6. Fourth derivative is 0. So 0 over 4 factorial times x minus 0 to the 4 is just 0. So that's why there's no term for x to the power of 4 in there. And then the fifth derivative is 1. And then 1 will go here, divided by 5 factorial, which we know is 120, times x to the 5. So that then gives us our plus x to the 5 over 120. So that looks pretty good. That's our answer for our Taylor polynomial. So now we want to check it in form of a graph. I've drawn a graph here. Now this dotted line is the real function for sine, as you can see, and then the black line, the solid line, is our Taylor polynomial. Now we wanted to calculate it as 0, so at x equals 0, which is here, this is the bit we're interested in. You can see it is absolutely spot on. So there's no variation in that at all. And it carries on all the way up to about pi over 2 and then starts to separate a little bit. Same to negative pi over 2 and it starts to separate a little bit. So what we can say is that our Taylor polynomial is very accurate, so we can be very satisfied with our answer. Okay, so there you go, and then you're done. So x minus x cubed over 6 plus x to the 5 over 120. Alright, thanks for watching. Any comments, please leave below.